Like I have it all done.
Okay, let's start today's class. Yeah, today we will talk about something new, but maybe not very new for some students. H-bridge. Have you ever touched this before? No? Never? H-bridge? Yeah, I think if you take the robotic, yeah. Actually, firstly, let's do a review for the lab 10. For the lab 10, we know you have already finished that, am I right? We know like for lab 10, you control the DC motor speed using PWM, am I right? Yeah, like in lab 10, you understand like a transistor switching, explore duty cycle and frequency effects, and perform some quantitative analysis. This is lab 10. But have you know, like if we use lab 10's method, we can adjust the speed for the motor, am I right? Yeah, but if you want to build like a small robot, yeah, actually you use that motor, like that wheel as a base, am I right? The speed is a very important thing, am I right? There is the other one. Actually, it's very important for a robot base. What's that? Do you know? Like yeah, for the robot base, like you know, like the speed is very important, am I right? Like the level 10 we talk about, like using the PWM to adjust the speed. There is the other factor to like very important for the robot base. Slowing down. It's speed, am I right? It's also speed. Huh? Powering?
Yeah, like powering the motor.
Yeah, but it's just let it run or stop run like that, am I right? Yeah, it's kind of speed. Yeah, when speed is zero. Yeah, you just like make it stop. You give it power, it will run. But there is one very important for the robot base. Yeah. What's that? Yeah, like a turn different direction. Am I right? Yeah. Today, like we will talk about how to turn different direction. Yeah. Okay. Today's lab is like a group lab, like a 2-person in one group, just like the other group lab. Yeah. So you need to find your partner. Okay. Then let's think about how do you make a robot like a move forward, backward? Yeah, because you can see for the robot base, you want to move it, let it turn right, turn wrong, turn left, and move forward, move backward. Am I right? How?
One wheel turns or one wheel goes a certain way and the other wheel turns.
Can you speak again?
It's based off of what wheels you're turning, what wheels are going in, basically.
Okay, like you mean the turn different direction,
Yeah.
right? Yeah, I think you are right.
And then they go backwards and forwards. It's just which way it spins.
Yeah. That's right. Yeah. Just focus on our class. Yeah. Okay. Today we will try to resolve how to like make a robot move forward, backward, turn left, turn right. Okay. And then let me ask you a question. Can we just connect motor to battery to make it in different direction? Yeah. Control it? Yeah.
If you hook up the battery, it'll like positive, negative, it'll move forward. But if you flip it, it'll move backwards.
Yeah. That's true. Yeah. So which means when the robot runs, and if you want to move forward, connect like one positive, the other negative. If you want it backward, you need to grab it and then change the battery's direction and let it. Do you think it is more complex for the robot? Yeah, actually, we have a easier way. I think you learn it in the actually robot class. Actually, like. I'm also a little confused. Like the microcontroller should be the first class before the robotic class. Yeah. But now, like some students I know, they take the robot and then microcontroller. I don't know why. Yeah.
They have the same question.
Okay. Yeah. Anyway, okay. Actually, you can see if we in lab 10, I don't know if you try to connect the battery directly with the motor. You will see the motor will keep continuously run in one direction. Am I right? So which means if you just connect motor to battery directly, it only spins one direction, no control, and cannot reverse. Yeah. So for today's lab, we will try to resolve this problem. And then how? Yeah, we need to direct control and safe control, no direct direction. Our control should be safe. Yeah. And then actually we will use one component. I just talked about in the beginning of this class. Do you remember? Yeah, H-bridge. Yeah, I think maybe you just use it in robot. Yeah, the H-bridge actually, H-bridge, it's a circuit. Yeah, similar. The simple idea is just like this. Yeah, you can see H-bridge is an electronic circuit that enables a voltage to be applied across the load. Yeah, for like a motor. Yeah, in either direction. Why we name it H-bridge? You can see it's it's like similar like a H. You can see it's similar like a H. And then you can see this is VCC, which means it's power, am I right? This is ground, which means if you connect this one and this one, then your current should be like this. That makes sense to you? Yeah, and then your motor should run in this direction. If you disconnect those two and connect this one and this one, your current should be like this. And then your direction should opposite. Yeah, that's the reason why the H-bridge can control the direction. Yeah, that makes sense to you? Yeah, actually you can see, maybe some students haven't taken the robotic, but H-bridge actually it's very typical. You can see it's very easy, but it can implement some control thing. Yeah. Okay, any question?
What is the switch? Like, is it like a relay?
What?
Like what switches because those are switches, right? S1, S2.
Yeah, it's switch.
So what switch is it? Is it like a relay?
Actually, different like H-bridge. Actually, if you use H-bridge, it's just a chip, am I right? Yeah, inside the chip, it has different different kind of switch. You can some chip they use delay, and some chip they just use mechanical switch. Yeah, some maybe in today's chip, actually they also use amplifier and then delay. Yeah, but you can use different kind of switch, but the most important is just if it can implement a switch function. Yeah, it can be used for the H-bridge. Yeah, that makes sense to you. Yeah. It depends. Yeah. In different circuit, maybe you use different switch. It will be better to use the specific one. Yeah, that makes sense to you. Yeah. Yeah. Honey, long time no see. Okay. No. Okay. Any question? Any other question?
No.
Okay, that's great. Okay, then this is the chip we use for today's lab, like L23, 293D. That's 3D. Okay, yeah, it looks like this. Yeah, you need to find the L293D in on the shelf and in the small drawers. Yeah, and then you will see for this chip, actually it is a dual H-bridge configuration. What does that mean? What does that mean?
That you can attach two motors to it?
Yeah, which means it has two. You can see one H like a bridge control one motor, am I right? Which means this one has two H bridge inside of the chip. Does it make sense to you? Yeah, and if you enable one, two, then this side will work. If you enable 3, 4, and this side will will work. And you can see it totally it has 16 pin, it is 16 pin deep package. And then we know, like in lab 10, if when we build this circuit, we just connect a diode to protect this circuit. But in today's lab, actually there you don't need to connect a diode. Yeah, because you in this chip there are some like built-in diode, yeah, for protection. Yeah, so you don't need to connect like actual diode for our for today's circuit. That makes sense to you? Okay, and then actually, if you observe this chip, you will find that there are two different power. One is there is a VCC1, there is a VCC2. Yeah. The VCC1 is a logic power. Do you know what does that mean? It's powered by logic, yeah. Okay, yeah, you know, like yeah, you know, like some companies, some chip, it is an active component. What does that mean? Yeah, yeah, which means it needs power to make this chip work. Yeah, this VCC just give a power to the chip, make the actually guess. I think some students may don't know like don't know that. You know, like we learn some students take the took the microcontroller. I'm right. We know like took the microelectronics. We know that amplifiers is an active component. I'm right. Yeah. Here, do you know why? Do you know why there is it needs like a supply, power supply? Because if you go inside this like chip, you will find there are 4 different amplifiers. This power is just try to make the amplifier works. Yeah, that's the reason why here needs a logic power. Yeah, it usually 5 volts. And also this VCC2, it is motor supply. Yeah, it is just give the power to motor. Yeah, that makes sense to you? Okay, any question so far? Okay, and then let's try to talk about the circuit. And in our like lab, actually the circuit is now complicated. You just need to connect the motor to different pin and give different pin different signals, and you don't need to connect actual items like the diodes, like the resistor, like the transistor. No, you don't need to connect this one. You just need to connect the motor to the chip and then give the power, different power, give signals to different pins like that. Yeah.
Using one motor, or we're gonna use 2?
At the beginning, you can use one, just make it run in different direction. But finally, you need to use 2 because today we will build a small robot base. Yeah. Okay. The L2 this chip is a popular H-bridge motor drive integrated circuit. It can drive 2 DC motors independently. Yeah, we know like this chip has 2 different sides, I'm right? 2 different H-bridge circuit. Yeah, actually one H-bridge can control one motor, which means 2 different H-bridge can control 2 different motor, and it can, yeah, that makes sense to you? Okay, and then it allows controlling both the speed and direction of each motor. Yeah, actually you can see this H-bridge chip not only can control the direction, it can also control the speed. We will talk about it later. Okay, any other question? No? Okay, and then you can see this is the power connection. Like I said, the VCC1 is just a logic voltage. It typically 5. It will give this chip a power. Yeah, and then VCC2, it is motor voltage. It can up to 36 volts. But for today's lab, you just connect it to 6 or 9. Yeah, that will be enough. Okay, ground is just a common ground for both logic and motor sets and all those circuits. Yeah. Yeah, you need to share the same ground. Yeah, okay. About the power connection, any other question? Okay. And then let's try to talk about the motor control logic. Yeah, you can see for one side, let's just talk about this side. Yeah, because this side is just control one motor, I'm right. And when the input one is 0, which means you just like set it like not working like that. Yeah, which means in this H bridge, which means this is this direction, which means the input 1, and this direction, which means the input 2. Yeah, similar like that. That makes sense to you? Yeah, and then for this one, which means this direction disconnected, and only this direction, like only one direction work. Am I right? And this in this status, it will be forward. The motor will forward, and the opposite, the input. This is 0 and this is 1. It is backward. Which means the direction will opposite. That makes sense to you? Yeah. Which means I think this circle. Yeah. Which means if you just make this input work, like it will go this direction, am I right? Forward direction. If you go make it this direction work, which means it will backward. That makes sense to you? One is just input 1, the other is just input 2. That makes sense to you? Any other question? No? Okay. And then there is one thing we need to talk about. If you just put 0, 0 to different inputs, it will stop. And if you just input 1, 1 to those 2 different inputs, will break. Let me ask you, what's the difference between stop and break?
How fast is it?
Huh?
How fast is it?
Yeah. I think you got it. Which how?
Stop is like it just stops, but break is like it slows down to a stop.
Are you sure?
That's what I'm thinking.
Yeah. Actually, yeah, you got the point, but it's opposite. Yeah, stop means you didn't do nothing and you just release power and release you just didn't give the power to the motor, but the motor has an inertial like a power. It will go a little bit until it stops.
So this is just a logic thing, right?
Yeah.
So for the stop, like the logic gate will just become 0, right? But the break is gonna return like a memorized number, right?
The break will memorize number?
Like so from microelectronics,
Oh,
I remember.
yeah, actually this one, yeah, it can be considered as a logic, but this logic, what's your question?
Sorry,
Yeah, I think yeah, like I said, just don't think it is just 0, 1, 0, 1. Yeah, the 0 which means 0, which means this current will now goes. Yeah.
I was thinking the clock.
Oh, okay. Okay, got it. Okay, yeah, like the break, which means you just like for example, you take the bicycle. Yeah, you just press the brake, it will stop immediately. Have you ever tried this before? Yeah. But if you just didn't take the pedal and just release the brake, release the pedal, and it will go like for a little bit. I'm right. If you take the bicycle. Okay, yeah. But don't like use the car like to test it. Just use the bicycle to test it. Okay, yeah. Any questions? Any questions? Any other questions? Okay, yeah. Like stops, like lets motor like course like that, and the brakes like stops it. Yeah, like that. Yeah, that makes sense to you. Okay, and let's continue. Okay, then we know like this H bridge complete. It can it also can control the speed. Yeah, but how? Yeah, if you observe this pin, this component, you can see there is a pin one. Pin one it enable like the 1, 2 circuit timer input 1, input 2. Yeah, if you use GPIO output PWM signal to P1 to this pin, and then you will know you will you will adjust the speed by change the PWM's what? Yeah, if you want to control the speed, you just try to connect the PWM signal to the P1, am I right? And then if try to change what to control the speed? Huh? Yeah, duty cycle. Yeah, that's very important. Just remember that. Okay, let me ask you a question. If you put PWM on direction pins, what will happen? Yeah, we know this input, this pin 2 and pin 7, it is a direction pins, am I right? Yeah, it control direction. If you just try to connect the PWM on these direction pins, maybe some students maybe think, oh, if I control the direction, firstly it go forward and then I let it backward, which means I just make it slowly, am I right? Yeah, but if you do that, what will happen? Yeah, which means if you give a pin 2 and pin 7 or like a PWM, which means you will give it high, it will go forward. Give it low, it will stop. Give it high, it will go forward. It will have the a shaking situation. That makes sense to you? It will stop, go forward, stop, go forward, stop. Yeah. And then your robot will not go smoothly, and sometimes it will generate the heating. Yeah, because it will stop, go like that. Yeah. So yeah, you can put a PWM on direction pins, but it's not a good way to control the speed. Yeah, the direction pins is just try to control the direction. That makes sense to you? Yeah, just try to remember that. Okay, and yeah, and when you try to use PWM, and try to set the frequency from 10 kHz to 20 kHz for smoother motor control. Yeah, that makes sense to you? Okay, any other questions? Yeah, actually, I just think about one, but yeah, let us continue. Okay, let's try to do a code review. Yeah, this is just a 3 pins you will use because actually for the challenge 1, I just let you to observe one motor. Yeah, let's try to know how to control the direction for one motor. Yeah, this is just the 3 different pins. One is for the enable. The other is just 2 different direction. Yeah, pin 1, input 1 and input 2. Yeah, this one is just enable, make this side work. And then 1A, 2A is just a direction. If you just put 1 in 1, 2 in 0, which means forward. If you opposite, it will be just backward. That makes sense to you? Okay, and okay, yeah, you can see for this one, yeah, it just enable it and let the 1A low and 2A high. It just forward or backward, and then try to flip polarity. Yeah, try to observe the different direction. Yeah, this is just the challenge 1. Yeah, any other question? Actually, I think this part will be easy. And then for the PWM, yeah, we know in your code, and this pin able is you just try to make it high, and oh yeah, I have I remember what question. Yeah, if you just give this pin 1 high always, what does that mean? This question is too general. What is the power? Yeah, the power is from VCC2, am I right? Yeah, and which means if you just give the pin 1 always high, it will give a full power to the motor, am I right? if you give a PWM, am right? Which means the speed, the power will depends on your duty cycle, am right? How to calculate the power? How to calculate the V supply? Yeah, like duty cycle multiple the V supply, am right? Yeah. Just remember that. Which means if you want to adjust the speed, you try to like adjust the PWM to adjust the like a duty cycle to adjust the power supply and then to control the speed. That makes sense to you? Okay. Yeah. Then let's talk about one thing. If you want to like try to adjust the PWM, then you just use this one. Actually, I didn't give you this code. Yeah, you need to like figure it out by yourself. Yeah, because I just in my code, I just let you to set the enable pin high, always high. But you need to think about how to adjust this pin, like to PWM input and let you to adjust the speed. Yeah. But yeah, we have already done that before, so it's easy for you. Yeah, but you need to do it by yourself. Okay, and then you try to adjust the frequency and duty cycle to adjust the speed. And frequency, I suggest you to set it to 10K, from 10K to 20K, make the motor smoother. And then try to, yeah. And why does this happen? Okay. Okay, I think I just, this is just the last ones. Okay, for the challenge one, you need to run up 30 seconds. Yeah, which means you need to make your motor like the speed from 0 to the maximum, and then hold 10 seconds, and then ramp down, like making your speed from the maximum to the low to the 0. And then hold it, then hold it a little bit, and then reverse, which means change the direction. Yeah, this is the challenge one. Yeah, any questions so far? No? And then challenge two, like how you need to try to build a robot base using two geared DC motors. Yeah, this is just like if you want to make this motor forward, you need to make the two motors forward. That makes sense to you? Yeah, everyone? Am I right? If you want it backward, you need to make the two motors backward. Am I right? If you want to make it like a turn, sorry, I think I just if you want to make it turn right, turn left, am I right? Yeah, which means you just stop the left and make the right, and it will turn right, am I right? Yeah, and if you want to turn left, which means you stop the right and make the like a left motor forward, it will turn left. That makes sense to you? Yeah, and for like challenge two, which means you need to like implement forward, backward, right, left, right. Yeah, that makes sense to you. And then actually for the challenge two, you need to navigate your motor from A point to B point. And then I will give you a maze. Like but that maze is not complicated. My idea is just like I will give you a point A and point B. You just make your motor from small like rock base from A to B. Yeah, and then I will give you a maze. This is there is a this is a start point, and then there is like a block, maybe the paper box, and if you're like a robot close to the paper box, and then your robot should turn to left, turn to right, and then get the final point B. Yeah, this is the maze I designed. Yeah, which means you need to make your robot from A to the block, and then turn left to the final point B. Yeah, this is what you need to do. Yeah, 2 people, 1 group. Yeah, I think it's now. You don't need to like you don't need to finish it like the robot like robot project. It should be very straight. You don't need to make it very straight. Yeah, but you need to finish the task. Yeah. Any other questions? Yeah, and then yeah, if you just use the distance calculation, to finish the task, yeah, you can get the full credit for the lab. If you use the sensor, like if you use the sonic sensor to detect if you near to the block or not, and then you can get a bonus. That makes sense to you. Okay, yeah, this is just the challenge 2. Okay, then let's talk about the common mistakes. Yeah, this is just similar with the other labs. No common ground, and battery now on, because we need the actual battery for the robot. And then the wrong pin mapping, if you connect the different the wrong pin to the circuit, and the motor weld backwards, if you just connect the motor maybe backward or is not what you want, it will give you a weird result. That makes sense to you. Okay, this is a common mistakes. This is just the lab 10. Actually, I think the theory part is not difficult, but you need to try to figure out how to finish the tasks. Any other questions about the lab 11? Okay, good news. Now a very good news. We have the one lab left. But how about your? Did you submit your final project report? No?
What do you think today?
Huh?
Like the update?
Yeah, update.
Yeah, we're gonna do that today.
Yeah, we're gonna put it in there.
Let me do a summary. How about that? How much percentage have you finished?
So.
50%? Group one. Who is group one? Yeah. Huh? 50%?
Minute, I have my people ready.
Okay.
It's coded, everything.
Okay. 50% like that.
75%.
Oh, 75. That's good. Okay. Group two.
We got what we know what we're doing.
You know what you are doing, or you don't know what you are
No,
doing.
we know what we're doing.
Okay.
We know.
Your cup is in the V.
Was it?
It's in that box.
So how much? 50%?
It's more like 20%.
Oh, more than 20%.
It's like 20.
Okay. And group three? Group three, I think is.
So we have the circuit done, I think all we need to do is just use.
Test? Okay.
Yeah.
Oh, okay. Like 16% at least, I think.
I say 50%.
Or 50%? Okay.
Yeah, like
And
the coding's not gonna be a lot.
Okay. Yeah, and how about the group D? Group 4?
We have an idea, we haven't built it yet though.
I'm pretty.
So how much percent? Yeah, because we have one lab left.
Yeah.
But I'm thinking about do we need to do that lab next week, or I just use that lab as a take-home exam like that? Yeah, because that lab you don't need some complicated items. It's just teach you, just lead you how to use Pico how to use Wi-Fi to control your Pico, like online control Pico.
Oh,
Yeah. Huh?
yeah. Take home will be fine.
Yeah, take home will be fun because we need to use Wi-Fi signals, and we can do it in the class. Yeah, but next week. Next week we'll like the Wi-Fi project. So give you the more time on the final project. Yeah. So which one do you think?
Yeah, more time on the final.
More time on the final project. Okay. Yeah. I will consider I will make that lab 12 as a take-home exam like that. Yeah. But the lab report you need to submit. Yeah. Okay. Okay. That's great. And we have almost 20 minutes left. So just focus on your final project. Is that okay?
Yeah.
Okay. Let me